Hello. In this session, we will do a bit of epidemiological study about the recent COVID-19 pandemic. To get things started, let's just define something called the case fatality rate. Case fatality rate is basically the proportion of deaths from a certain disease compared to the total number of people who have been diagnosed with the disease at the same time. So recently, there has been some studies on the situation in China with regard to COVID-19, and the reported case fatality ratio is approximately 2.3%. And there was another study by this group led by Tim Russell, which looked at the infection and case fatality ratio for COVID-19 using the data from Diamond Princess cruise ship. This particular cruise ship, which basically had some of the folks infected with COVID-19, and fortunately for us, they were able to study the entire group of cruise passengers who altogether were about, I think, 3711 total number of passengers. So the good thing with this study was that it looked at both symptomatic and asymptomatic cases. In general, when you look at a hospital, you only get symptomatic cases to work with. So the CFR, or the case fatality ratio in China, is basically 2.3%, is basically people who are actually symptomatic when they got admitted to the hospital. There is no, hence obviously it'll be kind of an overestimation, because actual case fatality ratio needs to look at even asymptomatic cases, that people who didn't show the symptoms even though they had the disease. So fortunately for us, the cruise ship situation, everyone was tested, and out of the 1,711 passengers, about 600 were infected. Now the actual total became around 700 later on, but this data was around March 10th or so of 2020, so it's going to be in that scope. Now let's look at this data and analyze it in more detail. For this, let's use the ability of ZCubes to convert any table in the content into a Calci. So now this area has become a Calci, and you can do all kinds of calculations here. So if you add up the symptomatic cases, and you can see the sum is 301 and the average is 33, and likewise the asymptomatic cases were about 318 in total, and an average of 35 for each of the age groups. Age groups, are by decade: 0 to 9, 10 to 19, 20 to 29, 30 to 39, and so forth until 80 to 89. However, in this paper, this column of number of passengers add up to 3,700, not 3,711 as is shown in the paper. Symptomatic cases, they combine the 90 to 99 age range, but unfortunately they didn't correct the number of passengers for 80 to 89. So the number, here, this should have been 3,700, but totally in the cruise ship there were 3,711 passengers. Now, the interesting thing is that there were symptomatic and asymptomatic cases. So you can see that the symptomatic cases were more than the symptomatic cases, and this has some really neat implications, and we will look at those in a moment. So let's take this area that we want to analyze out of here. So we'll just take this Calci out of here, and so now we have a table full of just that data, and let's just resize this so we can see it better. So to look at this in detail, we have the age range of the passengers on the left, followed by the number of passengers, the symptomatic cases and the asymptomatic cases, and these are the case fatality ratios that actually are the case fatality ratios for the age ranges from China. According to that, the expected rate of death should be what is in the column F. However, the number of deaths on the cruise ship was 7, and mostly among the older population. Though according to the case fatality ratios from China, it would have been much higher. Now let's try to understand what's going on here. For this, let's first make a graph, and for that we just select this area and say graph it, and let's take a line graph, for example, and that shows that. And here we will select category as X name so that we get the ranges, age ranges as the X-axis. And let's make this a bit wider so we can see the graphs clearly. And you can see that the number of passengers is the first curve here, and the infected people cases are shown at the bottom. The asymptomatic is the diamond and the symptomatic is the cross. Now you can convert this to all kinds of graphs, as you can see here, in different forms: bubble charts and area charts and radar charts and so forth. In the radar you would see that the symptomatic cases stay below 10%. So on an average they were both less than 10% of the total number of passengers we have to look at. Now, by the way, we can change the colors of all these just by going and selecting the colors here, or you can press Control and move your cursor and it'll automatically select new designs as you like. Now back to data analysis here. So we have this data here. So let's do something interesting. Let's expand this cube here and add a couple of rows, a couple of columns, append 2 columns and make it wider. So in this we will take the ratio of asymptomatic passengers. So that'll be equals asymptomatic divided by some less asymptomatic patients. Let me also insert So now let's take make a graph of the age range with respect to the ratio of the asymptomatic divided by the sum of the line graph on this, and see what it looks like. And as you can see, it also shows the category X name so we can see it clearly. This is really interesting. In age groups, the lower age groups, we have the higher number of asymptomatic versus symptomatic, and as after that 20 to 29 group onwards till about 60 to 69, the number of asymptomatic keep increasing, but there is definitely at this 20 to 29 range the asymptomatic patients are very less, and as age increases the asymptomatic and the symptomatic decreases. And that's a really unexpected kind of finding, but in a way it is explained by saying that the immunity response of a younger person is higher, so they're going to show the symptoms faster. However, if you argue from that perspective, with age, people with a higher age will not show symptoms for the longest time, but they could be carriers of the disease, and that could make some real unexpected results. The lower age people have less immunity, so they will have more asymptomatic patients. It appears that in COVID-19 both asymptomatic people can be transmitting the disease. Let's also look at some pivot table data here. We can go and pivot this information, and this is the pivot of this information. So let's put the number of passengers here and the asymptomatic and symptomatic passengers, and you can see that in this table this shows you the sum of the number of asymptomatic cases, but let's change it to the symptomatic cases. However, I would rather show you the sum over sum of the asymptomatic by symptomatic cases, because this is the real interesting thing here, that is showing that the number of asymptomatic cases in the 70 to 79 group is roughly the same as that of 10 to 19 group. Granted that the 10 to 19 group has a much lower number of data points here, but it does clearly show that increasing trend that you saw in the graph that we had here, or this not increasing trend, it's more like the interesting trend that we saw here is reflected in the pivot table here. Now we can look at this data from different perspectives like bar charts and so forth, but the row heat map kind of tells you a pretty interesting story here. And if you wanted to do, let's say, the sum of all the passengers, it adds up to 3,700, as we discussed before. Not 3,711, because the 90 to 99 groups were not exactly counted properly, and asymptomatic cases were 318, and most of the passengers who were detected or diagnosed with the virus was, as you can see, in the older range, and the symptomatic cases were also in the older range, but there were a lot of younger people in that. With this, you can do this facility of drag drop analysis. You can do get better insights about the data, and hopefully this demonstration kind of shows you that you can derive very interesting results out of standard paper data. This data comes from from a web page, and you can do some real serious analysis with it. Quite interesting that if you made this cube into an editable cube, we could go in and do a calculation here, and you can analyze things like that. So it gives you a lot of power in terms of data analysis, and hopefully that was helpful. So in terms of insight, there are some very interesting aspects we can take out of this data analysis exercise. One is that though in this data set there are a lot more 60 to 90 age group, the difference between the symptomatic and asymptomatic cases indicate that if, for example, as we are doing in New York, that we do testing only for symptomatic cases, we will miss a lot of old people. And it is likely that they may not show any symptoms, and at the end of the disease state, they might get into a more serious situation. And hence, it could be contrary to what the data is saying, what they're doing in New York at the moment, or the New York State is doing at the moment. It may also mean that instead of thinking of young people as the carriers affecting the old people, we should probably look at old people being carriers of this particular disease because they are not symptomatic as per the data. Again, these are all counter to our thinking in terms of general people's thinking about, or scientists thinking about this disease process. One of the interesting things that we thought about, it may or may not be true, is that this data might have some relationship to the smoking habit that many people had over the decades, and whether some of these older folks were affected by that in terms of how their ACE2 receptors in their lungs react to the virus, and whether that has anything to do with the way these different responses are showing. I mean, these are all open questions. We are not experts enough to answer those questions. I mean, these are kind of a layman's questions. Hopefully, some of these will give us more insight, and this sort of data analysis will help us get to that point. So thank you for listening.